Hi, my name is Callie Hocuff, and we are going to go over the fate of lactate and how lactate is used in the Cori cycle to allow us to create more ATP. So in overview, we're going to go over the major steps of the pathway. We're going to look at the Cori cycle and how it takes the lactate created from glycolysis, transports it to the liver, turns it into glucose, and then back to the muscle so we can use it. We're going to look at how exercise intensity and training adaptations affect the Cori cycle and the pathway that uses the lactate. We're going to look at lactate compared to lactic acid and the difference in that, even though people use them a lot of times as being the same. We're going to look at when lactate can be used metabolically, when it's most often used, when it's preferred, the preferred way of metabolism. We're going to look at how lactate accumulation affects our ability to exercise, and also at some other factors that can also influence exercise cessation. So first, we're going to look at the Cori cycle and the pathway that lactate travels through. So on the left we have, this is a muscle, so if this page was split in half, you're in the muscle on this side, you're in the liver on this side, and then the blue arrows are blood. So when we're in the muscle, first starting here, we're going to go through glycolysis. So we're going to start with glucose. It's going to be converted into pyruvate. Once there, if it's anaerobic, we are not going to have oxygen to turn that pyruvate into acetyl-CoA. So what's going to happen is lactate dehydrogenase is going to convert the pyruvate into lactate. Once that happens, the lactate can't be used in the muscle again. So what has to happen is the lactate is going to be transported out of the muscle through the blood into the liver. In the liver, gluconeogenesis is going to occur. So the lactate that traveled from the muscle into the liver is then going to be converted into pyruvate, and then it's going to be converted back into glucose, which is then going to be transferred from the liver through the blood back to the muscle so that it can then go through glycolysis again so that we can make some more ATP. Also, what happens when the pyruvate is converted into lactate is NADH is converted back into NAD+, which can then be used for glycolysis again. So it's a cycle that allows itself to continue to repeat. So when we look at the effects of exercise on the lactate pathway, so if we look at what the lactate threshold is, it's the highest oxygen consumption or exercise intensity achieved with less than 1 millimole increase in blood lactate concentration above the pre-exercise level. So the lactate threshold is kind of the point where the highest point we can get before we have a sharp increase in the lactate levels in our blood. So high intensity aerobic activities, anaerobic exercises use this pathway more, and this is because if we're in aerobic state, we have the oxygen needed to take the pyruvate and turn it into acetyl-CoA. In anaerobic conditions, we don't have that oxygen, so it has to be turned into the lactate, which we can see in this. So glucose to pyruvate, if there's no oxygen, it has to be turned to lactate because we don't have any way to be turned in to go into the Krebs cycle. So pyruvate is, that's why pyruvate has to be converted into lactate and then go to the liver to then be converted back to glucose that can be used in the muscle, because our muscle can't use the lactate itself for energy. It has to be converted back to glucose. When lactate is being produced faster than it can be converted to glucose, then it begins to build up, and this is where we will eventually hit that lactate threshold, and then the lactate levels will increase very quickly. Training at or near the lactate threshold is a great way to help increase that level. So, and if we can increase the lactate threshold, it'll help us increase the amount of time we can do work, the amount of energy we can spend before we hit that threshold. So if we look at lactate versus lactic acid, lactic acid is different from lactate in that it has an available hydrogen ion that it has to donate. Lactate is an anion, and it's different from lactic acid because it's already dissociated from the hydrogen ion when it's in the lactic acid state. Lactate is what is produced during anaerobic glycolysis because lactic acid quickly releases that hydrogen ion that then has to be buffered, so it doesn't stay lactic acid very long. And we can see in this picture the difference. Lactic acid has the extra hydrogen, and lactate does not have that hydrogen anymore. When lactate is used metabolically, so lactate is used the most during high intensity exercise. All of the different pathways are used at the same time, but certain conditions, environmental factors will affect which is the preferred way for our body to get the energy it needs. So during high intensity anaerobic exercise is when lactate is mostly going to be used for energy. And this is just, as we talked about before, when oxygen is available, it doesn't have to go through that process, and we don't have to turn as much of it into lactate because we have the option of going into the Krebs cycle. Other factors that influence exercise cessation, respiratory disease can play a large role in the ability to exercise. COPD, it can lead to the cost of breathing at rest to be tripled, which means if that person then starts to exercise, it's going to be so much harder and they're not going to be able to go for very long just because the incredible amount of energy it takes for them to breathe. Cigarette smoking causes an increase in peripheral airway resistance, which leads to reduced exercise capacity because breathing is not as easy. It makes it a lot harder to get the oxygen and everything in and out. Also, internal pH that falls outside of the typical range, especially of our blood, can play a role because our metabolism likes a very small range to be in the pH for it to work properly. And these are my references, and that is the fate of lactate.